Okay, so today we're going to start 1-2. Our objectives for today, we're going to be solving linear equations. Okay, so we're going to create and solve linear equations with one variable using the properties of equality. So 1-2, solving equations. Okay, so let's jump right in. We're going to find the value of x in the equation, 2 times the quantity x plus 4 all over 3 minus 8 equals 32. Now remember, when you're solving for x, you want to do the order of operations backwards, okay? Or get x by itself. To do that, we move whatever's furthest away from x first, and then we go from there. So if I'm looking here, x has a whole bunch of stuff happening to it. Okay, this minus 8 over here, though, is kind of by itself. So the first thing we should probably do is get rid of that minus 8. How do you get rid of minus 8? Plus 8. So now I have 2 times x plus 4 over 3 equals 40. Okay, again, our goal is to get x by itself. X still has a lot happening to it. Okay, let's get rid of this bottom because that's what's making it more difficult. So how do I divide by 3? Or how do I undo dividing by 3? You multiply by 3. Okay, so if I do it to one side, do it to the other, and those cancel. Left with 2 times x plus 4 equals 120. Now, this next step, you have a couple different options. Say you can absolutely distribute, or if you want to get rid of that times 2, you divide by 2. My assumption is most of you will choose to distribute, so let's go ahead and distribute. I get 2x plus 8 equals 120. From here, simple two-step equation. Minus 8, 2x equals 112. How do I get x by itself? Divide by 2. X equals 106. Okay. And there's our first problem. Okay, please pause the video and try this problem. Okay, this problem 4 plus 3x minus 1 all over 2 equals 9. I'm going to write it again just so I have some room to work. Again, get what's furthest away from the x gone first. So I've got this positive 4 hanging out. How do I get rid of that? Minus 4. Now I have 3x minus 1 all over 2 equals 5. Okay, again, the goal is to get x by itself. This dividing by 2 is making things more complicated, so let's get rid of dividing by 2. How do we do that? Multiply by 2. Do it to one side, do it to the other. 2's cancel. 3x minus 1 equals 10. Finally, nice, easy two-step equation. Add the 1 to both sides. 3x equals 11. Divide by 3. And leave it like this. Okay. You could change it into 3.67 if you want, but you need to make sure you're very careful with your rounding. Leaving it as a fraction is much more accurate and it's cleaner. Okay, so please leave it as an improper fraction. Okay, next example. We're going to solve consecutive integer problems. Okay, so again, this book likes to give us a problem and then teach us how to do it. So the problem is the sum of 3 consecutive integers is 132. What are the 3 integers? So the first thing I'm going to ask is, what does consecutive mean? Okay, consecutive, if I'm talking about students in 3 consecutive desks, means 3 desks in a row. Okay, so consecutive integers are 3 numbers in a row. Okay, so integers that are in a row or are in order. Okay, so example of a consecutive integer, 1, 2, 3, 7, 8, 9. Anything like that are consecutive integers. Okay, but this problem, however, we don't know where these consecutive integers start. So my starting point, let's call it x. Okay, I'm starting at x. How would I get to the next number in the row? Okay, how do I get from 1 to 2 or 7 to 8? Well, you just add 1, right? So it's x plus 1. Okay, and then I would add 1 again to get to the next number. So I would take this x plus 1 and add another 1. okay, which really gives us x plus 2. So when I'm talking about consecutive integers, you always start with x, then you go x plus 1, x plus 2, x plus 3, and so on and so forth. Okay, so now let's dissect this problem. You should see the word sum. What does sum mean? Sum means add. Okay, so I'm adding these 3 consecutive integers. So let's add our 3 consecutive integers. First one was x, plus my second one was x plus 1, plus my third consecutive integer, x plus 2. And then you should see the word is. Is means equals. So I know it equals 132. Okay, so how would I solve this? Well, solving it algebraically, we want to start with combining like terms. Remember, like terms have the same exponent and the same variable. So I see a bunch of x's together. And remember, when you have just a plain old x, the coefficient is 1. So I have 1 plus 1 plus 1. Gives me 3 x's. Okay, my other like terms are my constants. I have 1 plus 2. 1 plus 2 is just 3. Okay, so let's solve for x. Obviously, minus 3. I get 3x equals 129. Divide by 3 on both sides. X equals 43. Okay, so what did the problem actually ask us to find? It wants to know the 3 integers. I only have one number here. So let's think about what we had. We had x was my first number. X plus 1 was the second number. And x plus 2 was my third number. Well, we know what x is. X is 43. So my first number is 43. My second number is going to be 43 plus 1, which is 4. And then x plus 2, again 43 plus 2 this time, is 45. So my 3 consecutive integers, 43, 44, and 45. Okay, so now, hang on, let's look at this sign first. Okay, so whenever I'm talking about consecutive integers, you always start with x, x plus 1, x plus 2, x plus 3, and so on. Now let's talk about, real quick, consecutive odd integers. Okay, so think about 3 odd numbers in a row, like 3, 5, 7. Okay, so again, we always start with x. How do I get to 5? Well, I add 2. And how do I get to 7? X plus 2 plus another 2. So really x plus 4. Okay, so consecutive odd integers are going to be x, x plus 2, x plus 4, x plus 6, and so on. Consecutive even integers work the same way. Like if I had 2, 4, 6, and start with x. How do I get to 4? Well, you just add 2 more. 4 to 6, I would add 2 more again, x plus 4. So if you see consecutive odd integers or consecutive even integers, you're going to use the same thing. X, x plus 2, x plus 4. Okay, so pause the video here and try this problem. Okay, the sum of 3 consecutive odd integers is 57. What are the 3 integers? Okay, it might be helpful. I know I'm doing 3, so first number, second number, third number. Okay, consecutive odd integers. So I know the first number is x, second number is x plus 2, third number is x plus 4. Okay, so now dissect the problem. We know sum, so I'm going to take x plus 2 plus x plus 4. Okay, and we know the word is, so it equals 57. So from here, just combining like terms. So I have 1, 2, 3 x's. And my constants, I have 6. From here, you're just solving for x. So minus 6. 3x equals 51. Divide by 3. X equals 17. Am I done with the problem? Not yet. I only have one number. I need to get my 3. So my first number, x, is 17. Then second number is x plus 2. So it's going to be 17 plus 2. So that's 19. Third number is x plus 4. So 17 plus 4 gives me 21. So my three numbers, 17, 19, and 21. Example 3, word problem. Yay, everyone's favorite. So we're going to use linear equations to help us solve mixture problems. Okay, now these problems you need to make sure you read very carefully. Okay, so lab technician needs 25 liters of a solution that's 15% acid for a certain experiment. However, she only has a solution that's 10% acid and a different solution that's 30% acid. Okay, so we're going to have to mix these two solutions together to get our 15%. So we need to know how many liters of the 10% and how many liters of the 30% solution should she mix to get what she needs. Okay, so I like to start with what do I need? 25 liters of the 15% acid. How can I represent that? Okay, I'm going to make that my equals. 25 of, that means times, 15% acid. Okay, whenever you work with percents, you should automatically change them to a decimal. So remember, 15%, I'm going to move that decimal once, twice to the left. So that's really 0.15. We'll take this times 0.15. Okay. So let's start with the 10% acid. Okay, 10% is 0.10. Do I know how many liters she needs of the 10%? No, I don't. So I'm going to say X. Okay, so I'm going to make a note. X equals liters of 10% acid. Okay, and I'm mixing it, so that should say plus 30% acid. 30% is 0.3. But how many liters do I need of that? Well, how many liters do I need total? I need 25, right? So if I use X liters here, and I have 25 total, how many do I have left? I have 25 minus X. Okay, if you think about it, if I know I needed 10 liters, and I know this one had to be 6, how many liters would the other one would I have to use? 10 minus 6, or 4. Okay, so this is one where you need to be very careful. Okay, 25 total. I use X over here with the blue, so I need 25 minus X for my purple. Okay, now, since it's set up, I can go ahead and solve. So the first thing we should probably do is distribute. Okay, so 0.10x plus, okay, I don't know 0.30 off the top of, times 25 off the top of my head, so let's do our handy dandy calculator. 0.30 times 25, 7.5. Okay, so I get 7.5 minus 0.30x equals, and you can go ahead and multiply this together right here. 25 times 0.15. 25 times 0.15. Okay, 3.75. Okay, so now we're going to combine our like terms. I see some like terms here. 0.10 minus 0.3 gives me a negative 0.2. Okay, so now finish solving. It's just a two-step equation. We're going to subtract 7.5. Again, I don't know that off the top of my head, so let's do that real quick. 3.75 minus 7.5. A negative 3.75. Last step, divide by negative 0.2. I get 18.75. Does this answer the problem? Well, I needed to know the liters of the 10%, the liters of the 30%. Well, I know X was the liters of the 10%. So I need 18.75 liters of 10% acid. How much do I need for the 30% acid? Well, remember X was the 10, so 25 minus X was my 30%. So I'm going to do 25 minus X for my 30%. So 25 minus 18.75. I get 6.25. So I get 6.25 liters of the 30% acid. Okay, and this right here is my final answer. Notice I was very careful to answer both parts. Okay, your turn. Please pause the video and try. Okay, so again, I'm going to start with what I need. I need 20 of the 30%, so 20 times 0.30. Okay. Now I'm going to start with the 5%. Okay, 5%, remember move it twice, once, twice, so it's 0.05. And I'm going to call that x. So x equals 5%. Okay, and I have that 45%, so plus 0.45. Okay, so I need 20 total, so 20 minus x is my 45%. So it's going to be times 20 minus x. Okay, and from here, we're going to distribute. Okay, so 0.05x plus 0.9, I think. Let me check that, 0.45. Oh, it's just 9. Minus 0.45x equals, I think it's 6. 20 times 0.3. Okay, let's combine our like terms. 0.05 minus 40.45 is negative 0.40. X plus 9 plus 6. Subtract 9. Negative 0.40x equals negative 3. The last step is to divide. X equals 7.5. Okay, but now we got to think to ourselves, what was x again? X was my 5% acid. So I need 7.5 liters of 5% acid. Okay. 20 minus x gives me the 45 acid. Okay, so now I'm going to do 20 minus x. So 20 minus 7.5, I get 12.5 liters of the 45% acid. Okay, and both of these numbers together gives me my answer. Okay, example 4. We got another one here, another word problem. 4 friends use an online code to get discounts on concert tickets. They spend $312 for the 4 tickets. What is the price of 1 ticket without the discount? Okay, so I know that they spend 312. So my equation equals 312. Okay, so how many tickets did I buy? I bought 4. Do I know what the original price was? No, so let's call that x. I got it discounted though. Okay, notice right here it tells you how much it was discounted. So discount means I'm going to subtract the 15. Okay, notice I kept it all in parentheses because x minus 15 is the ticket, but I want to know that I need 4 of them, so it's 4 times the entire thing. So let's go ahead and solve. Start by distributing. 4x minus 60 equals 312. Okay, just a 2-step equation. So add 60 to both sides. 4x equals 372. Let's divide by 4. X equals 372 divided by 4, 93. So the original cost of that ticket, $93. I don't know about you, I wouldn't pay that much. Right. So here's another problem. Please pause the video and try. So the same four friends buy tickets for 2 shows on consecutive nights, use a coupon for $5 off each ticket. They pay a total of $416 for 8 tickets. Okay? So it's set up the same way. Okay, so it's going to equal 416. Okay, how many tickets am I buying this time? Buying 8. And I don't know the original price, but it's $5 off. So I'm going to do x minus 5 inside those parentheses. Okay, so now we're able to solve. Distribute. 8x minus 40 equals 416. Add the 40 to both sides. 8x equals 456. Oh, divide by 8. I get $57. And there you go. Okay, last example. Work and time problems. Latanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. She expects to wait 30 minutes for the repair. Then she'll ride her bike home. Can she be home in 1 hour? So when you have problems like this, the biggest thing you need to remember is D equals RT. Distance equals rate times time. Okay, so we've got some different things going on here. So the first thing we need to do is she's going to walk her bike. Okay, we have 3 things to think about. So the first thing is the walk. Okay, then she's going to wait. And we know that's 30 minutes. And then the last thing she's going to do is ride. We have 3 different scenarios to look at. So let's start with the walk. Looking at the picture, it tells you I walk at 3 miles per hour. Okay, distance, rate, time. Okay, I know it's 1.5 miles. Okay, so D equals RT. 1.5 is my distance. Do I know how fast she's going, my rate? Yes, I do. That's 3 miles an hour. Do I know how long it takes? No, so we call that T. We can solve for T. Okay, divide by 3. Okay, so 1.5 over 3 is 1/2 hour. So that's my time here. Let's look at the writing now. Again, we're doing distance equals rate times time. Distance didn't change. That's still 1.5. How fast does she bike? Well, 10 miles an hour. So 10. Do I know how long it takes? No, I'll keep that T. Okay, so if we solve, divide by 10. 1.5 divided by 10 is 0.15. Okay, and that's in hours. So the question says, can she be home in 1 hour? Well, I have ½ hour here, 30 minutes here, 0.15 of an hour here. What's my total time? 30 minutes. That's not the same unit as the others. 30 minutes is how much of an hour? 30 minutes is ½ an hour. So if I add these 3 things together, ½ plus a ½ is 1 plus 0.15. So I'm really gone for 1.15 hours. Will she be home in an hour? No, she will not. And that's the answer to that problem. Okay, last one. Try this one, please. Keenan will run 2.5 miles from his house to Jared's house. Plans to hang out for 45 minutes before walking home. How long will he be gone from home? Again, split into 3 scenarios. First thing he's going to do is run. Okay, then he's going to hang out. And I already know hanging out is 45 minutes. Okay, third thing I'm going to do is walk. Again, I'm using D equals RT. So let's talk about the run. Distance is 2.5. How fast do I run? Oh, 6 miles an hour. Do I know the time? No. So let's solve for time. right? 2.5 divided by 6. 0.417. So 0.417 is what t is. Okay, so we know that's in hours. Okay, let's talk about walking. Again, b equals rt. Distance doesn't change. It's still that 2.5. This time I'm going 4 miles an hour, and I don't know how long it'll take. Divide by 4. T equals 0.625. Okay, so how long will I be gone? Does 0.417 of an hour mean anything to you? Doesn't mean anything to me. So to go from hours to minutes, we're just going to multiply by 60. Let's take this times 60. Okay, 0.417 times 60. Well, that's 25 minutes. Okay, so this is 25 minutes. 45 minutes. Okay, 0.625, let's multiply that by 60. Okay, again, to change it to minutes, so it's 37.5. So add all of these together, I get 70 minutes here, 107.5 minutes total. So that's how long he'll be gone. Okay, so that's what I have for you. Homework tonight, page 15, you're going to do problems 5 through 9, 11, 12, 18, 21, and 24. If you have any questions, please let me know.